Okay, let's have a class, and we will talk a little bit using Blackboard, then I will using the slides to go over it about meat tenderization. So this is what we talk about on Tuesday. The meat tenderization, the tenderness is important compared to flavor, juiciness. And how we measure the tenderness, we using shear force value, or we do the sensory evaluation with the 9-point hedonic score. And this is basically the muscle structure. It's a bounding system from muscle bundle, muscle fiber, lemma or sarcoplasmic reticulum. Then the single unit will be sarcomere, myofiber, myofibril, myofilaments. And then if we cut it perpendicular, we will get this screening shots. And the screenshots what you have is a sarcomere, which means the distance between Z line, and you have the Z line is the middle of the I band, and then the middle of the sarcomere is the M line, that's the middle of the A band. And the middle of the H star and the C star H star. And then you have these actin myosin cross link will be formed if you do the muscle contraction. And then surrounding the Z line, you have lots of other proteins, which like nebulin, desmin, and titin, all those. So this is like a review. What's the muscle structure related to tenderization? Now, regarding the tenderization, there is two major things we haven't mentioned, but I do want to mention here. Now, before we mention the two important issues, we would love to just very briefly go over what we talk about the rigor mortis. So we talk about is rigor mortis. And the curve is supposed to be, looks like that. And the x-axis is the time, and the y-axis is using shear force value, or sometimes we do the percentage, which means the different components. And we know there is this time, at the beginning, after the harvesting of the beef carcasses, you will have a delay, or we say it's an onset phase. That means rigor mortis has not been started. Then started to have a rigor mortis, and there is a peak value reached. So this is, we call it a rigor mortis time. And later on, what happened is resolution. Resolution phase, because proteolytic will start to have, the reason is the cowpen activated by calcium, they started to hydrolyze these proteins surrounding the Z line. Therefore, the muscle started to become tender. So that's a picture. But we also need to include in those important index here. So for example, when you see here what happened, we could draw this curve. This is basically is ATP decrease like this. And we also could draw another curve, which is a pH curve. And the pH curve is always decreased relatively rapidly. And at the end, if you want to put another line here regarding pH, that should be for the beef about 5.5. Now that's 6.0, 6.5. 7.0, that should be around the 5.5, because we talking about the PI value usually is 5.0 for beef. So that's usually the pH. Another thing very important, why we have this delay of the rigor mortis because there is a residue creatine phosphate cell. So the creatine phosphates, they decreased also like that. So that's another curve, which is called creatine phosphate curve. So those three curves, including the Rigg-Mortz curve, which is tells you what happened after the slaughter of a carcass. So this is related to beef. Now, regarding the tenderization, there is two major things happened in the meat industry around the world and the United States. Number one is called PSE. What means a PSE? Which means the meat is pale, soft, and exudating. I just want to make sure. EXUDATIV. So how you understand about this? This is something like you put a meat products, cut it into a basin, the basin which all the container have the water. Then it will be completely reflection the light. So it looks like it is white. It is like white. So we say it's a pale. Now obviously we do not like these type of the meat products. Now which meat products will be the risk for this? Basically is pork. This had happened in 1960s. And then in 1990s, there's a research showing Turkey could also be a risk group, have PSE. Okay, now why the PSE will happen? We could explain to you the thing based on what we talked about already. This is happens, number one, is pH dramatically decreased while the temperature is still high, around 37 degrees Celsius. So pork is a little bit different from beef. Pork, after 45 minutes post-mortem, the pH should be around 6.7 to 6.8. If the PSE happens, the pH will be around 6.0. So for the pork, this pH is very close to the PI of the pork by themselves. Okay, this pork is about 5.8 for the pork. Beef is 5.0. Then what happened? This will cause the contractile protein denatured, therefore causing very low water holding capacity. So which means water cannot hold, so everything will be extracted on the surface. Then will cause PSE. Okay, now why it will cause PSE? What's the reason behind it? There are two major reasons. Is stress. So we talk about animal welfare during the harvesting, before harvesting. We can, regarding the transportation, okay, relate to cannot mix of different animals, different animal from different resource. and that's related to the animal welfare. However, they also have a genotype reason. There are certain type of the pork, because of the breed issue, they are more susceptible to the stress compared to the other breed. So we call it PSS, porcine stress syndrome. Okay, what are those PSS pork looks like? So this needs to back to talk about this sarcolemma reticulum. Okay, so we could draw up right here. So sarcolemma reticulum, we know it's related to calcium release and absorption, resorption. Once the muscle contracted, this calcium will be released from the sarcolemma reticulum, SR, and the relaxing it will be come back. SR have two major proteins. One of them is called YRY, and another one is DHPR. And RYR, the full name is rhinodine. This is a major protein responsible for the calcium release and absorption. DHPR is dihydroxyperoxidine. This is not that important, but in certain species is important. Okay, so RYR is important. Now, for these type of the PSS pork, there is only one gene base find the mutation of it during the RYR, which is thymine becomes cytosine. So you can understand from physical structure, this is we talk about. This is a thymine, okay? Because of the point mutations, it becomes a cytosine. So that's NH2 here, H, NH, H, double bonds. And we know that there is a replication, transcription, translation happened. When that happened, one gene base change at the end of, they will change protein sequencing. And the protein sequencing related to amino acids, and here what's going to be changed is the cysteine will become arginine. So what the cysteine looks like? CH2, SH, then becomes arginine. So you can understand it from it's like a no charge amino acid become a chargeable amino acids. And this is arginine. So CH2, 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 but not enough NH, CH2, H2 plus NH2. So you see the structure is changed. Okay. Once this structure changed, what happened? The calcium will be dramatically released from SR. And we talk about once this happens, what they need to do. The ATP will become ADP and the phosphates. Now, how they do this? If the carcass has already been harvested, they can only do this, rely on glycolysis and coupled with fermentation. So what happened? pH will be dramatically decreased because lactic acid is generated. So that's one of the reasons we'll have PSE, because of the genotype have PSS. And the PSS, we also give them a name. We say it's a malignant hypersemia. This is the one is people they did the research. If they have a PSS genotype there, the swine and the pig, if they exposed to halomethane, they will have been like kind of like very stressful, like very stressful. They cannot even standing very stable, which means they will be very sensitive to the halomethane, the reaction. They did some animal behavior research about that. So that's another thing. They come up with this name called malignant hypersemia. Okay, so that's one of the reasons, talk about genotype. Another thing we want to talk is Nepal gene. This is, we also call it allele. The Nepal gene allele, we call it RN. Okay. This is another type of the genotype, the swine and the pork we should be avoid during the breeding. What happened is, this is because of the gamma subunit of the 200th amino acids change of RYR. It causes glutamine becomes arginine. So you know what is glutamine looks like. That's glutamine. Okay, arginine is right there. Glutamine becomes arginine. So what happened is, there is a product called AMP kinase. Adenine monophosphate kinase, related to ATP. This guy should be inhibit glycogen synthesis. So therefore, you should keep amount of the glycogen in the body. However, because of this allele RN, the AMP kinase, the function is destroyed. So you will be end up with extremely high amount of glycogen. This will cause a big problem because you have extremely high amount of the glycogen, which means during glycolysis and fermentation, you will take a longer time to do. And more dramatically, the glycolysis will happen. So the pH will be decreased more than normal. So instead of they go 6.7 to 6.8, they will be around 6.0. So that's another reason will cause PSE. So PSE in the pork products, what we should do is avoid the stress. However, the breeding is important. And this is in the history we find if the breeds have PSS and the allele RN, these we should be avoided. Okay, so this is just something want to be introduced to you. Okay, the next one we want to talk about is the DFD. Gary, do you mind just move this to the center so we can... Yeah, just cover the whole blackboard. Yeah. That should be good. Okay, PSE will talk about rate to the pork. So DFD will be the risk for the beef. But the story will be a little bit similar, a little bit different. So what's that? This means it is dark, firm, and dry. Now certainly we don't want that. Now by the way, the PSE in the history, there has been caused a damage like $5 to $10 million of economic loss for the pork industry. BSE is more than that in the history. Now why will happen to this? This is the reason is not enough glycogen. Therefore, the pH is extremely high. How high it is? Around 6.0 to 6.5-ish. This will cause what's the problem? This is a way too much from the PI 5.0. So we go back to talk about this pH, water holding capacity. This is 5.0. This is around here, almost. That's way too high. Okay, once this happens, the water will be contract and absorbed. So which means you only have absorption of the light, there's no reflection of the light. So that's why it becomes dark. And obviously all the water is in there, so you become very, very dry. What happened is their maximum separation of male female. And they also cause is reducing fraction of oxymyoglobin. Myoglobin is responsible for red to brownish color. Oxymyoglobin is very cherry red, we'll say. Very red. And if you're reducing that one, it's going to be showing you go to the brownish color. Okay, so that's why it looks like brownish color. Now, compared to the PSE, which talks about the stress and the genotype, The DFD basically is a reason, is weather, is season. So winter time, it is cold, it is wet, and it's much more easily to happen compared to the summertime. So DFD is a major reason, is a seasoning. There is no other. We also call it a damp weather. Okay. There is no other major reason for that. If you could have avoided the harvest season, then should be avoided. Could be avoided from the principles behind it. Okay, so we finished talking about here. Then we want to talk about another thing. Relatively briefly. So we mentioned about these related to the muscle structure, but there is another thing we haven't mentioned, is the collagen. And the collagen, this is a major components of connective tissue. So I just write it CT. So major components of the connective tissue. Now related to the tenderness, there is a theory which is called intramuscular fat. We also give them a name called marbling scar. Will be affects the tenderization, because those fat more or less could be squeezed or even break down certain part of the collagen to make it more tender. So there is a theory about that. Okay, so this is we're using the slides to talk about. Now collagen. This is the one, if you're using X-ray diffraction methods to do the observations of morphology, it is triple helix. And to forming this triple helix, there are 3 stages. The first stage is pre-collagen processing. So the pre-collagen processing basically is these triple helixes. Okay, so they form like that. We're going to add another one sometimes like this. Okay, I'll just draw like 2. We draw like that. So we'll do a pre-collagen processing. So pre-collagen processing, they need some of the structures there. Lots of them need amino base. They need a carbonyl group. So they need an amino base, a carbonyl group there. Amino base need a carbonyl group somewhere. Base and also carbonyl group. And the second one they will do is self-assembly. Self-assembly. Self-assembly, they will connect it with each other using non-covalent bonds. So I can draw another one. It's like this. Triple helix. These are well called non-covalent bonds. Let's say hydrogen bonds, sometimes hydrophobic bonds. So that's called self-assembly. The third thing is last thing, very important. They will have a progressive cross-linking. This is rely on covalent bonds. They want this link is relatively strong. So what happens if I have these things like that? I'll just draw a couple. So they connected, and for themselves, they will be connected like this. And this is covalent bonds. That's the cross-linking will be generated. Okay? Now, when we talk about the collagen, there are lots of different types will be generated, including type 1, 2, 3, 4, and 5. But in this muscle structure, basically is type 1. And type 1 there is composed by 2 alpha 1 bands to combine with 1 alpha 2 bands based on their secondary structure. They have a 3-dome domain. When we talk about the triple helix, this is basically is right in the middle. So all these things is a protein, and the protein, when we talk about the first primary structure, which is related to the amino acid sequencing, we will be talking about N terminal and C terminal. So N terminal, central, and C terminal. And they have those 3 domains. And both N terminal, this is a non-triple helical domain. And also the C terminal is non-triple helical domain. And in the center, which is responsible for 95% of the whole components, that is a triple helical domain. So then we go back to ask your going to be next question. So you have a structure. You have these secondary, tertiary structure talks about what their primary structure looks like, what their amino acid sequencing looks like. Their major sequencing is glycine with proline with hydroxyproline, then will be with lysine, and sometimes will be hydroxylysine. So then people do those sequencing amount comparison. They find that the hydroxyproline and the hydroxylysine is responsible for more than 60% of the amino acids in the collagen. Now, what are they? We should know about that. The proline, this is we mentioned a couple of times. You have to draw the whole structure. CH2, CH2, CH2 goes back, and this is will be OH. So that's hydroxyproline. Okay. And hydroxylysine know what the lysine looks like? NH2 to C, COH. This is H. So you have a very long chain. CH2, 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 NH2. On the top you have OH. This is the hydroxylysine. So that's what the amino acid sequencing looks like. Glycine, you know, it's only H. Okay. So next one, we also want to mention something is collagen. When you heat at 60 to 70 degrees Celsius, around 30 minutes, what will happen? It will shrink. Therefore, it comes out with ST value shrink temperature. This is something tells you, if the collagen is shrink, it will become very tough. So, you know that if you cut a beef from a carcass, even buy a beef from the grocery store, then you cook at a relatively low temperature. Put in the water, you boiled for 30 minutes, you took it out, it's very tough. Because the collagen of the meat will be shrink, and you cannot even bite it. You'd better only like cook maybe 2 minutes, it's better to use sometimes. If you cook any of the steaks in the boiled water for 30 minutes, it's going to shrink and become very tough because the collagen will be glued like. So, what we have to do, you're going to be to heat at a relatively high temperature, 80 degrees Celsius. Same thing for 30 minutes, sometimes you don't need it. Then what happens, the collagen will become soft. At that moment, you are feeling the beef is not tough anymore, it's become very soft. Because at that moment, the collagen becomes gelatin. Becomes gelatin. And this is what we call insoluble protein becomes soluble protein. So, this gives us some information about gelatin. So, there is a 3 types of the gelatin, which is alpha, beta, and gamma, based on their molecular weight. A gelatin's molecular weight is very high. This is 80 to 130 K. This is roughly 145 to 240 K. This is 250 to 375 K. Okay, that's a gelatin, 3 different types of the gelatin. Now gelatin, in the food industry, we also could do is 2 treatments. There is called type 1 gelatin, is using acid treatment. And the type 2 gelatin is using lime treatment, which means using alkaline solution. And if you use lime treatments, usually will give you a very good commercial viscosity. Okay, so that's a gelatin. Now, if you add it into the cold water, then what happens? It will swelling in the cold water. So that's something I want to cover here. And what is the gelatin's sequencing, amino acid sequencing, which is glycine, it is glycine, proline, and hydroxyproline. Okay, so if you want to draw by yourself. So we talk about chemistry, so you should know this goes here. CH2 goes back, so you go here, BNH, so you go C, H, H2, CH2, CH2 goes back, this will be OH. Okay, so this is a very quick. We talk about all these things related to the PSE-DFD and also the collagen. Okay. Now we're gonna talk about the slides. So I'm gonna turn this